This is part 2 of chapter 1, Atomic Structure for AQA GCSE Chemistry. So we're going to jump straight in with the history of the atom. And there are questions that come up on this very, very regularly. We've got to have an awareness of how this developed. So we're going to start here though with a few questions about models and how ideas change over time. So try these, then we'll review the answers. So essentially, models are useful and we use them all the time because they help us to take something that's quite abstract and see it in a way that's easier to visualize or recall. Atom ideas have changed over time because we've got bigger technological advancements. We have apparatus now that we couldn't have dreamed of 100 years ago. So we're able to see things much more clearly with much greater clarity. We know that there are 3 types of subatomic particle. Why would scientists have been surprised by this? Well, they believed the atom was the smallest building block from which everything was made. They had no comprehension there could be anything within it. Again, they didn't have the technology to see it. And then finally, we've got the diagrams. Pause and take a look at these. We would tend to do this now with formulae, but it's good practice to think about how things are bonded together. There they are. Okay, we've got a few questions here to work through. Try these. At some point, you're going to need to pick up a periodic table and have that handy to do the tasks that follow. Taking a look at number 1, the subatomic particles found in the nucleus are the protons and neutrons. The electrons, as you will hopefully remember, are orbiting that nucleus, or they're surrounding the nucleus in clouds. The atomic number is the number of protons, and the mass number is the number of neutrons and protons. Moving on, we'll talk a lot more about those later on within this video. Is neon a metal or a non-metal? It's a non-metal. We can identify that from its position on the periodic table. It's on the right-hand side. And there are more metals than non-metals. They make up approximately 75% of the table. Next few questions for you to try. And now let's take a look at the answers. So neon has 10 protons. Its atomic number is 10. Neon also has 10 neutrons. Now that's because its mass number is 20. We take away its atomic number, 10, and that leaves us with 10. Radium has 88 electrons. That means it also has 88 protons, because in an atom, the number of protons is equal to the number of electrons. For number 9, what could we do here? Well, we could dissolve in a larger volume of solution. And the reason for that is you are making sure that all of the salt has dissolved. Now, the next question asks what we would need to do to also collect the salt crystals. Actually, you would still need to filter so that we could keep the sand separate, but we would then evaporate the solution so we were left with the salt crystals. And the final question here, there are words that you might or might not be familiar with, but you hopefully know that what goes through the filter paper is the filtrate. Moving on, have a go at filling in this table. And it's a very important table. You have to know what is included in here from memory and use it very, very regularly. Now, the relative charges, proton positive, neutron neutral, electron the other one. That might help you to remember that proton is +1, neutron is 0, and the electron is -1. In terms of the relative masses, the proton and neutron have a relative mass of 1. They're equal to each other, but the electrons are much smaller. We can say they're negligible. If you want to be really specific, they're 1,836 times smaller than a proton or neutron. Now we're going to try to reinforce some of the key ideas about the periodic table. Have a go at these questions. And the atomic number tells us the number of protons. That means that lithium has got 3 protons. And the mass number tells us the number of protons and neutrons. So lithium, with a mass number of 7, would have 4 neutrons, because I have the 7 and I take away 3, the atomic number. For the next task, have a go at filling in this table and answer the question down at the bottom. So the symbols always provided in the periodic table, so they are there for you to use. Atomic number is also provided on the periodic table. You will not need to remember them. And actually, I'm going to jump ahead and fill in 2 columns next, because I want you to see the 3 columns in yellow are identical to one another, because the atomic number is the number of protons, and in an atom, the number of protons is equal to the number of electrons. Now, from there, I am going to add in the mass numbers, again, direct from the periodic table. And using the information from that last activity, my number of neutrons is going to be the mass number subtract atomic number. So boron, 11 take away 5, 6. Hydrogen, 1 take away 1, 0. Hydrogen is very much the anomaly as the only atom to have no neutrons. In terms of the easiest way to remember, don't think about where they're written in the periodic table because that is subject to change. The mass number is always the larger number of the two. Again, hydrogen is the exception to that. More questions for you to test yourself on here, see how you do. And direct from the periodic table, atomic number 82 for lead, so 82 protons. Atomic number 54 for xenon, so 54 protons, and therefore 54 electrons. And number of neutrons in mercury, I do my mass number, take away atomic number, and I get 121. Next task, have a go at answering these questions. And again, these are ideas that we've already touched on. In an atom, the number of protons and electrons is always equal. We're going to look at what happens when they become unequal and what we have when it's not an atom anymore. So, why is it less easy to suggest how many neutrons? Well, neutrons don't really do anything. They're not involved in reactions. So for that reason, it's not as straightforward to see how many there are. Neutrons were actually discovered much, much later for that very same reason. So we are going to go on and look at ions, and this is a very long, drawn-out process to show you how an ion is formed. But I really do urge you to try to go through this systematically so that you can get to the final answer. What you will find is this becomes a lot more straightforward later on. So let's deal with the first 2 questions. How many protons are there in a beryllium atom and how many electrons? Well, the atomic number is 4, so there are 4 of each. Now we know that the charge on one proton is +1 and on one electron is -1. So my total charges are +4 and -4. And if that's the case, my overall charge is therefore 0. Now for beryllium to get a full outer shell, which is what it will do when it reacts, the easiest way to do that with an electron configuration of 2-2 is to lose 2 electrons. So with that in mind, let's now go back through and count the electrons and protons. I now have 2 electrons, total charge of -2. But I've still got 4 protons, total charge +4. So my overall charge is +2. Now to finish it off, that is written as a superscript, so my ion is written as Be +2. Have a go at the same thing with potassium. Okay, moving on to the answers. It has an atomic number of 19, so that's 19 protons, 19 electrons, total charge +19, total charge -19, so my overall charge is 0. But potassium, when it gets a full outer shell, does so by losing 1 electron. That means it now has 18 electrons with a total charge of -18. But it still has 19 protons with a total charge of +19. So the total charge, -18 plus 19, is +1. And so I would write that as symbol for potassium is K. K plus, I don't need to put the number when it's a +1. That's very much assumed. We're going to do another one. Let's look at fluorine. Atomic number 9, which means 9 protons, 9 electrons, +9 and -9 charges. For an atom, the overall charge is 0. Fluorine is in group 7, so the easiest way to get a full outer shell is to gain 1 electron. That means it now has 10 electrons with a total charge of -10. It has 9 protons still with a total charge of +9. So my overall charge of my -10 and +9 comes to -1. And so I'd write it as F-. I have written the 1 on there. It's acceptable to do, but it's not necessary. For the next task, have a go at completing this table. So from the periodic table, let's look at the group numbers, and I can put those in. Lithium, sodium, potassium are all in group 1. Beryllium and magnesium are in group 2, oxygen and sulfur are in group 6, and fluorine and chlorine are in group 7. Now, what else can we take from there? Well, if we look at their electron configurations, and we'll build on this later, group 1 have got 1 electron in their outer shell, group 2 have 2, group 6 have 6, group 7 have 7. From this, you can probably work out group 4 have 4, group 5 have 5. Now, we've already touched on this previously. What's the easiest way to get a full outer shell, which is what happens when the ion is formed? Group 1 will lose 1 electron. Group 2 will lose 2 electrons. Group 6 will gain 2 electrons. Group 7 will gain 1 electron. So following the process through that we've just done numerous times, we can get to the charges. And we can see, hopefully, some patterns here. Group 1 ions will always be +1. Group 2, always +2. Group 6, always -2. And Group 7, always -1. Next task for you, have a go at answering these 4 questions. And we will take a look at the answers. So we know that the neutrons are found in the nucleus along with the protons, and from the table earlier in this video, they have a relative mass of 1. We've said about this 2 or 3 times. You work out the number of neutrons in an atom by taking the atomic number away from the mass number. And we now need to introduce the idea of isotopes. So an isotope is the same element, same number of protons, same number of electrons, but a different number of neutrons. That also means it has a different mass number. Now let's take a look at an example of that, have a go at these tasks, and then we'll review. So knowing that it's mass number take away atomic number, we can see that A has 18 neutrons and B has 20 neutrons. Now, will that have an impact on the physical properties? No, it won't. Physical properties and chemical properties actually are determined by electrons, so neutrons will have no bearing on that at all, and that will come up in later chapters. 2 more questions for you to try. And now let's review. So the majority of the mass of an atom is found in the nucleus. Now remember, protons and neutrons have a relative mass of 1. Electrons are almost 2,000 times smaller, so that helps you to understand why. We would say that an unstable isotope is radioactive, and the number of neutrons and protons gives us the mass. We know that because it gives us the mass number. For number 8, well, number of protons, we have an atomic number, 92. We also know that in an atom, number of protons equals number of electrons, so we also have 92 electrons. To work out the neutrons, repeating this once again, mass number take away atomic number, so we have 143 and 145. So moving on, getting close to the end of the topic now. Electron configurations are things that you need to draw out. I want you to pause, read through these rules, and then move on to the next activity so that you can try to draw them out. Moving on, try to draw out the full electron configurations for the 4 that are provided. So we're going to take a look at the first 2. Hydrogen has 1 electron. The first shell can hold 2 electrons, so I put the 1 in the first shell. But beryllium has 4 electrons. First shell can only hold 2, so the second 2 electrons go in the second shell. Carbon has 6 electrons, so 2 go in the first and 4 go in the second. And neon has 10 electrons, so 2 go in the first and 8 go in the second. The second can hold 8, so both of those are now full. Now have a go at these 4. And you can see here, magnesium has got 12 electrons, so 2 go in the first shell, 8 go in the second shell, that leaves 2 to go in the third shell. And magnesium is in group 2, so we'd expect 2 in the outer shell. Phosphorus is in group 5. There are 5 in the outer shell because it goes 2, 8, 5. Potassium is in group 1 and its electron configuration is 2, 8, 8, 1. And calcium is in group 2 and its electron configuration is 2, 8, 8, 2. So we're reinforcing the idea that group number also tells us how many electrons are in the outer shell. We've now got some questions on shorthand electron configuration. Try these ones. Taking a look at lithium, 2, 1. It has 3 electrons, 2 in the first shell, 1 in the second. Fluorine, 2, 7. 9 electrons, 2 can fit in the first shell, that leaves 7 in the second. Aluminium, 13 electrons, 2 go in the first shell, 8 go in the second shell, because that's then full, and that leaves 3 in the third shell. Another task for you to have a go at here, try to fill this table in, and then we'll review. So the electron configurations 2, 1, 2, 8, 1, 2, 8, 8, 1, all have got 1 electron in the outer shell. They're all in group 1. Fluorine and chlorine, 2, 7, 2, 8, 7. They both have 7 electrons in the outer shell. They're group 7. Beryllium and magnesium, 2, 2 and 2, 8, 2. They both have 2 electrons in the outer shell. They're in group 2. And finally, bringing us to the end of this topic, oxygen and sulfur are in group 6. Their electron configurations respectively are 2, 6 and 2, 8, 6. So as I say, that takes us to the end of the atomic structure topic. A lot of what you've talked about or reviewed in here will come up in subsequent topics. So it's definitely worth going through these as a foundation to build on.